Man according to race, genes and heredity began.
Ahnen spätestens für das ewige Leben des Deutschen.
And the process to produce a superior human being was on. The Master Race on People Century, Friday premiere 12.
Well, time travel may still be science fiction, but the time machine I've come to see is science fact. I'm standing here on the Greenwich Meridian line, the point from which all world time is measured. And above me here, they're about to put the most accurate clock in the world to count us down to the millennium. The clock itself is being kept under wraps in the basement of the old Royal Observatory. And where else could it be but here at Greenwich?
In 1884, when we set up the International Time Zone System, Greenwich was set as the prime meridian. So it is the 0 point for measuring all time and all space on Earth.
Time and space are fundamentally linked because time is a measure of the movement of the stars. Our units of time reflect the movements of the Earth. A day is the time it takes our planet to rotate once. A year, the time for it to orbit the sun. For centuries, these movements were thought to be constant, and the task of the earliest clockmakers was to find the most accurate way of measuring them. But as timekeeping technology has progressed in the 20th century, we've become more aware of the limitations of the ways we measure time. We now know that the Earth wobbles on its axis and doesn't rotate at a uniform speed. It's actually slowing down, which means that tiny discrepancies can creep in, so that even the most precise of clocks have to be adjusted. Today, we rely on 240 precise atomic clocks around the world. An average of their readings is the International Standard of Time. It's called Coordinated Universal Time, or UTC. And then it's over to the astronomers to work out what adjustments are needed and when.
What we've also got is a number of telescopes dotted around the Earth. And what they're doing is looking straight up. And they're the ones who are looking at the fabric of the stars. If they notice that the stars are moving more slowly, i.e. we're moving more slowly, then they're saying, uh-oh, you've got to add a leap second. So it's this combination of the astronomer, if you like, keeping us honest, with the clock people keeping us precise.
It's a tall order for any single clock, no matter how precise, to have the responsibility of counting down to the millennium. But the designers of this clock have come up with an ingenious solution. I'm on my way to the secret location to find out the answer. Well, here it is. It's not the most beautiful clock I've seen today, but it is the most accurate to a millionth of a second. Kristen, how does it achieve that?
Well, what this clock does that no other clock does is it actually receives a signal from the GPS satellite system.
GPS satellites are normally used to give precise locations on Earth. But they also transmit very precise time signals by comparing UTC time on the ground with their own atomic clocks on board. And because these clocks are in space, they aren't affected by any wobbles on Earth. The Millennium Clock will take the average time from up to 5 satellites at once. Right now, that's about as accurate as you can get. Getting a mechanism that's precise to the nearest millionth of a second is an impressive feat.